Hey everyone, so let's solve this LeetCode hard problem. Count subarrays with score less than k. So we are given the definition of score of an array, which is defined as the product of its sum and its length. So for example, if the array is 1, 2, 3, 4, 5, then the sum would be 15 and the number of elements that we have means the length of array is 5. So 15 into 5 is 75. Hence the score of this array is 75. Now we are given a positive integer array nums as well as an integer k. Now we need to return the number of non-empty subarrays of nums whose score is strictly less than k. Means the sum of the elements of that subarray into the length of subarray is less than k. Okay, and I hope the definition of subarray is clear. So simply for suppose if the array is this, so subarray will be 1, then 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, then 2, 2, 3 means all possible continuous segments that we can get. Okay, so for example, if the input is this and the k is given as 10, so let's see the subarrays which will have score is the exact means strictly less than k. Okay, so suppose if we consider the subarray 2, so it will simply have a score of 2 into 1, 2. So all the single elements, as we can see, like all the elements are less than 10 only. So all one length subarrays will be true. Now let's consider two length subarrays. So if we consider two length subarray 2, 1, so sum will be 3, 3 into 2 will get 6. Let's consider another subarray 1 and 4. So it will be 1 plus 4 into 2, which will be 10. Now it is not less than 10, right? This condition is not true. So hence we will not be considering this as a valid subarray. Similarly, if we consider any 2 length subarray or any 3 length subarray, we will not be getting like score strictly less than 10. So hence only like all 1 length subarrays as well as this 2 length subarray are the answer. Hence the total number of subarrays that satisfy the condition is 6 only. And hence 6 is the output here. Okay, so what will be the brute force approach to solve this? Since we need to like for each subarray check whether its score is less than k or not. So what we'll do, we simply iterate through all possible subarrays. So suppose I is the starting point of each subarray, this means we'll move for I from 0 to n minus 1 and j is the end point of each subarray. So j will move from I to n minus 1. Now when we have this subarray I to j, what we'll do, we'll calculate its score. Okay, so score will be what? It will be simply sum from I till j into what? Its length. So length will be simply j minus I plus 1. And we see like if like score is less than k, then we simply like increase our count by 1. Okay, so this will be the approach of this problem. If we like now we have two ways of like calculating this score. So either we'll be like calculating this sum where for iterating for k from I to j. So in that case, what will the time complexity? Time complexity will be n into n into n. So it will be n cube. Or we can maintain a running sum, initialize this sum here and then do sum plus equals to nums of j at each step. So now we'll be able to get this sum of elements from I to j in constant time, and hence we'll be able to calculate this score in constant time as well. So we'll be able to avoid this loop and the complexity would be big of n square. Okay, so this will be like the brute force way of solving it. Let's see the code for this approach. So what we'll do, we simply initialize the total count that we have initially as 0. Now we'll maintain this current sum. For the subarray I to j, we'll increase this sum and calculate the score. So if sum into j minus I plus 1 is strictly less than k, that means we have a valid subarray and we'll increase this result count. And in the end, we'll return it. So the time complexity will be simply big of n square. So let's see the constraint. So n can go up to 1e5. So obviously this will be like going up till big of 1e10, which will obviously give us TLE here. Hence we need to think of some optimizations here. So the first observation that we need to make is we need to count the number of subarrays which satisfy the condition, right? So based on like the problem here is to count number of subarrays. Okay, so what algorithms means can come to our mind? Maybe we need to make some formula, then like play with it, bring it in the form of single variables, and then use like prefix plus hash maps. Okay, maybe we can do that. The second thing that we can do is we simply need to like count the number of subarrays. So maybe like we can use 2 pointers. 2 pointers plus like slide the window. Okay, slide a window and see like for the current window means for current ending j of the window, what will be the like the leftmost part that we can get for which satisfies the condition, and all the subarrays will be part of it. Okay, so maybe we can do that, or what we can do is maybe we can apply dp. What dp of I will be storing? The number of subarrays ending at j, ending at j. But this will be same that what we will try to do with 2 pointers as well, right? So here we will be simply using this extra space. So this means instead of using this, we can use 2 pointers only. Okay, because we can maintain I to j and we will be able to calculate the number of subarrays ending at j using these 2 pointers only. So you don't need to like separately store using dp. Okay, now the means the dilemma is between these two approaches. So which approach to use here? So we see like, are we given any formula here? Like are we supposed to like find some pairs ij such that like we are given some relation between nums of I and nums of j, and then we need to means play with the subarrays? Are we given any formulas? No, we are not. So hence like we can try to avoid like thinking in that direction, in this direction. Okay, so the approach that we can think in the direction of is like applying using 2 pointers and then finding out the means the maximum means stretch the window at maximum as possible and then try to shrink from the left. Okay, for each j. Okay, so what we can do is means let's try to explore this approach now. So what we'll try to do is we'll fix right end. Okay, now suppose I have fixed this right end at j. So what do we want? I want the leftmost point I that I can get such that the sum I to j into j minus I plus 1 is less than k. Okay, so I can maintain 2 pointers initializing it with I equals to 0, j equals to 0. Now what I will do? I will do this sum till this score is less than k. Okay, now as soon as this score becomes greater than equals to k, what do I need to do? If I am at current j, I need to move this I forward. Okay, so suppose this score j1, this is j1. So if score j1 became greater than equals to k, what will do? I need to move I forward. Okay, I need to move I forward while this score j1 is greater than equals to k, right? So now if we move I forward, what will be the result of this? It will be the result that I will move this some position I1 and will have this j1. So now I1 to j1 will be the maximum limit that we'll have for this j1, because we know as soon as we like include more elements in our window, this score value is going to increase only because all the elements are positive and this length will be increasing by a positive factor. Okay, so hence means the score will be increasing only as soon as we like try to include more elements. So hence we try to means find out the leftmost point we can have such that this score is less than k. Okay, so while it was greater than equals to k, we try to shift it this I forward. Now for this current j1, we'll be able to calculate the number of subarrays which end at this j1 as what? Either it will be this subarray simply, or this subarray, or this subarray. Means all these subarrays which end at j1 will definitely have a score less than k only, because this entire subarray from I to j1 has a score less than k. So hence if we means exclude this element, then the score is tend to decrease only, right? So hence we'll be able to get means a lower score only. So in that case we'll be getting all the subarrays which end at this j and start any point afterwards I1, we'll be getting that count. So what will be the count of this? It will be simply like j1, then means j1 minus 1 to j1, j1 minus 2 to j1 till I1 to j1. The number of subarrays will be get simply r minus l plus 1. So j1 minus I1 plus 1. Okay, so hence what we'll do? We can simply maintain these ij pointers. Now I will move I in such a manner such that we get the segment I to j, which is I is the leftmost segment for this particular j, and for this segment the score will be increased by factor j minus I plus 1. Now we want for this j we have calculated. Now we want to calculate for j plus 1, right? So now we have the subarray I till j plus 1. Now how do we find for j plus 1? So we know that for the sum I to j, this was the most stricter point, right? That means if we have included one more element from the left side, then this score would have tend to become greater than k, right? So for this j1, either this strict point will be lying here only or further forward as well only, because we know like for this part, if we try to include this element, then this part only would have made the score greater than k. So hence for this j1, if we try to think like maybe its left point can lie at I minus 1, so this will never be the case, because obviously from I this I minus 1 to j only, we would have got a score greater than k. So if you try to move from I minus 1 to j plus 1, the score will be further greater than k. Okay, so obviously for j plus 1 the leftmost point will be lying greater than equals to I only. Okay, so now if we have this point I to j plus 1, one doubt is clear that for this the leftmost point will be lying ahead only. So again we'll follow the simple approach. We'll move this I forward while the score of j plus 1 is greater than equals to k. We can move this I forward. Okay, we'll keep moving it forward till a point such that this I reaches a point such that this I to j plus 1 becomes a valid segment such that its score is less than k. Okay, and again we'll increase our the total count with this formula j minus I plus 1. Okay, so I hope the doubt is clear, like how two pointers is going to work here, and how for a particular, once we have calculated for a given window, and when we move forward, we see like the leftmost point for this new point that we'll have will either lie greater than or equals to I1 only. It will not be dependent on previous elements. Okay, so hence we'll not be getting any extra subarrays for this geo, and hence since we'll not be getting any extra subarrays, hence using sliding window will be like the most preferred approach here. So I hope the approach is clear. We'll simply maintain two pointers, initializing with 0. Now we'll move them as we required, means we'll move I till the score is greater than equals to k. And now after we have done that, then the score would have become less than k, and then for this particular j, we'll be able to find out the result. Means find out the number of subarrays ending at that particular j. And then in the next iteration, we'll increase the right side by 1, means move to j plus 1, and then again move I from the left. Okay, so this is the simple approach that we'll follow, and since I and j will be moving till the end, means at max it will be I will reach to n minus 1 and j will reach to n minus 1. So the maximum time complexity that we'll have will be of the order of 2n, and this will be like the expected approach that we need to come up. Okay, so this is how we move from the brute force approach, means from the n cube to n square, and now 2 big of n. We try to analyze different different algorithms that we can apply, and then try to see like how to eliminate thinking in those directions. And then we try to explore the 2 pointers plus a sliding window thing, and we saw like for a particular j, it is not dependent on like previous values. Okay, so we can simply move the window forward and we will be able to calculate the result for a particular j. So this is the overall approach for this problem. Let's try to see the code as well. So this is a simple code that we have. We initialize this result initially as 0. We'll maintain this total, which will be like the score, means which will be the sum of the elements, sum of I to j. And to get the score, we'll simply multiply this total with the number of elements that we have, j minus I plus. So what we'll do, we'll increase, we'll have the new element nums of j. Now we need to move this I forward till this score is greater than equals to k. So till the total sum into the length is greater than equals to k, we'll like remove the left part. So we'll initially I is there. So if we want to move it, we'll remove the sum nums of I from total. Okay, so we'll remove nums of I from total and increase I forward. Now again we'll see like whether this score is greater than equals to k. If it is still does, then we'll move I further forward till the score becomes less than k. Now if we have reached this position, either like if it would have been the case, like if suppose a single element only, means this nums of j is greater than k, then what would have happened? So in that case, j would have been here and I would have become here, means I would have pointed to j plus 1. So in this case, what we will do, we will simply get j minus j plus 1 plus 1. So it will be 0. So we will be increasing our result by 0 if this nums of j is greater than k. Okay, and in all other cases this I would be lying less to the left side only. Okay, so hence if it is possible for a particular means ending at j, then we would get the result. Else if it is not possible, means this particular nums of j only is greater than k, then this nums of means I will point to j plus 1 after this loop is executed, and hence we'll be like adding 0 in this case. Okay, so we'll keep doing this and in the end simply return result. So initialize, what we did, we initialize this I as well as j with zeros and move j from 0 till n minus 1. And for each j, we try to maintain the leftmost point which you can have for the current window, and we simply increase our result at each. So this is like the big of 2n approach using a sliding window and 2 pointers here. So let's try to submit this code as well and see like how well it performs. This is the same code that we discussed of the order of complexity 2n, and it should run, yeah, it runs in 0 ms because n can go up to 1e5. So yeah, because it is means the most optimal. So I hope you were able to compare means make up a comparison between approaches and how to decide means which approach to think in the direction of. And yeah, if you yet have any doubts remaining, feel free to comment down. I will be happy to respond. Thank you so much for watching.